Hello, everyone. And today we're going to be discussing ocean systems. I'll give you a little brief introduction to the structure of the oceans. And then we'll talk a little bit about human interactions with the oceans and some of the problems that engenders. And then also end up giving you a little bit of a lift at the end by telling you some of the ways in which the problems that have arisen are being addressed. And they are being addressed. Not always as fast as we would like, but nonetheless, there are many people and many organizations which are addressing ocean conservation, which is what we'll finish off with. Okay, so our planet is rightly called the blue planet, and more than 70% of the surface of our planet is covered with water. And it is thanks to the existence of water in its liquid form that life was able to evolve here on the planet. And if you think about it, the planet which is next closest to the sun from us is Venus. And Venus, the surface of Venus is far too hot for liquid water to exist. There is water on Venus, but it's all water vapor. The planet next out away from the sun from us is Mars. And Mars, there is solid water in the form of ice. And there may be some subterranean water. We don't quite know yet. But what we do know is that Mars once had liquid water on its surface, but it no longer does. And in general, it's considered that the water exists only in those two forms, ice and water vapor on Mars. So there's no liquid water. Our planet is often referred to as the Goldilocks planet because it is exactly in the right position. It's exactly the right position for water to exist in all three of its forms, of its molecular forms. And those are water vapor in the atmosphere, liquid water, oceans, lakes, rivers, etc., and then solid water, which is ice at the ice caps in glaciers and those sorts of things. But most of the planet is covered with water, and it gives it this beautiful blue look from space. And if we were to go, this is North and South America, and around the corner here would be Europe and Africa and Asia. If we were to go to the other side, if we were to just turn this 45 degrees around, what we would see, 90 degrees around, what we would see would be facing the Pacific Ocean, and the Pacific Ocean occupies almost an entire half of the planet. It's quite an extraordinarily large ocean. So if we look at all of the water on the planet, we find the total amount of water is about 332 million cubic miles of water. Now that sounds like an enormous amount, but if we were to gather it all into one single drop, not a droplet, but a drop, would be a giant drop. Here it is here, that's all the water of the planet. The total amount of water in the oceans is about 330,000 cubic miles of water. And the rest of the water is the total amount of fresh water in both river streams and in glaciers, etc., is about 2,500,000 cubic miles. Not very much at all. So if we were to look here, this is the total amount of water. This here is the total amount of liquid water not in the oceans. And this here, that tiny little dot of blue there, is the amount of fresh water easily available to us as liquid fresh water on the surface. We've discussed this before when we talked about water issues. Now, the result of this, most of the planet is covered by ocean, which is saline water, and it has salt in it at about 3%, 33 parts per thousand. And the oceans comprise an enormous collection of ecosystems. We could think of different areas of the ocean as being different biomes, but it's 99% of the biosphere, of the livable portion of the planet, is contained in the oceans. Only 1% of the livable areas of the biosphere are up on land. There's something important to be said about that, and that is we actually know very little about the oceans. Given their size and given the diversity of habitats and ecosystems in the oceans, we know very little about the functioning of the ocean. And we know even less about different species. There are many undiscovered, undescribed species of organisms, both plant, animal, bacterial, etc., in the oceans, which we have yet to understand. The oceans in general are a great mystery to us in many respects. And that is important because we make huge use of the oceans. So here, a map of the world, and just to show you, there are 6 continents, 1, 2, 3, 4, 5, and the 6th is Antarctica. So that's 6 continents and 5 oceans: the Pacific, the Atlantic, the Indian, the Arctic, and the Southern Ocean, which runs around Antarctica. So 6 continents, 5 oceans. And when we look at it just as it is, just about 70% of that is water. So the oceans have distinct structure, not only over their distribution around the planet, but also when we look vertically through the oceans, we see that there are distinct areas. I don't need you to know all of the area. If you're interested, certainly you can read up more about it. But what we are particularly interested in are these relatively surface areas here, which are called the epipelagic, which is where there is enough sunlight that organisms can photosynthesize very actively. Then there is an area here also closer to the surface than the rest of the oceans, called the mesopelagic. And this is sometimes called the sunlight zone, and then the mesopelagic is the twilight zone. There is light there, but it is difficult for organisms to, photosynthetic organisms, to really be highly active photosynthetically. And then below that lie the deep areas of the ocean called the bathypelagic. Most of the ocean floor is abyssal or abyssopelagic. Pelagic simply means out to sea, and as opposed to coastal. And then there are areas of the oceans which are extraordinarily deep. And the deepest of all is the Mariana Trench. And the Mariana Trench is about 6.8 miles deep. So that is extremely deep. And of course, the structure of the floor is not flat. It varies tremendously. It has tremendous variability. And some of the greatest mountain ranges on the planet are actually underwater in various places. And here's one here, shown here. This would be what is referred to as a seamount. And most of the seamounts are extinct volcanoes. And they are fairly common, and they have a particular relevance to what we're going to be talking about a little bit later. So those 3 layers, the surface layer, which is more brightly lit, is generally warmer, and the deep ocean is extremely cold, 4 to 8 degrees. And there's a tremendous difference between the surface and the deeper layers. And there is actually a boundary layer between them, and that is called the thermocline. Thermocline refers to the fact that if we were to go down, you'd find the water would stay relatively warm, and then very suddenly it gets cold as you enter the deep water. And that when we do that, when we move through the thermocline, what we find is not only the temperature changes, but the density changes. And that's due to two things. First of all, deep water is much more saline. It has far more salts in it. So it is denser than the surface. The surface is receiving a lot of rainfall all the time. That's just one of the reasons why it has a lower salinity. Also receives the water from rivers, etc. So it has a lower salinity as we move vertically through the ocean. We go through that surface, warm surface, brightly lit layer. We hit the thermocline, and suddenly the temperature drops, the density increases, and the salinity increases. And that creates a barrier. It is a quite profound barrier between the surface and the deep layers, and mixing between the two seldom occurs. It only occurs over a very long period of time. They don't mix easily. Wave action, it does not penetrate very far down we call it the water column. Wave action does not penetrate far down the water column to mix. And instead, mixing is very, very slow and rather difficult. So here are, when we look at the oceans, the oceans provide us with a tremendous amount of ecological services. We depend on the oceans for many different things, some of them exploitative. We actually do things to extract services from the ocean. Others are just provided to us as a normal part of the functioning of the planet. 80% of oxygen produced on the planet is produced by marine phytoplankton, and that is from the processes of photosynthesis in that very narrow surface layer where photosynthesis can take place actively. But a lot of that oxygen, of course, is used up by the ocean itself. It dissolves into ocean water, but is used by oceanic organisms. And about 40% of the air that we breathe on the land comes from the oceans, the rest from forests and all sorts of other plants and photosynthesizing organisms. The second thing that's important about the oceans is that they are the great climate modifiers. They make it possible for life to occur on a very wide area of the land. They modify the climate by redistributing heat. Now, if you don't understand that, go back to our discussion about biomes, because we talked about that, about how oceans redistribute heat around the planet. A very good example of that is the Gulf Stream in the Atlantic Ocean, which runs right past the east coast of the United States, then dives across the top of the Atlantic and impacts on Europe. And it is thanks to the Gulf Stream that Europe's temperatures are temperate. If the Gulf Stream was to stop, Europe would be plunged into what would amount to a mini ice age. It is kept in a temperate zone by the influence of that huge current, the Gulf Stream, which distributes heat from the tropics all the way up to Europe. So the third thing is, of course, that we depend on the oceans for as a source of food. And about 17% of our protein globally is marine in origin, and from all sorts of things. Fish, from mammals, unfortunately, but it is true, mammals are still providing a source of protein for many, especially indigenous groups. Invertebrates, which are widely used and a major source of protein, things like shrimp, mussels, clams, scallops, all of those sorts of things. And then also algae. Of course, there are many different algae in the oceans, and depending on the culture that you're raised in, the use of algae may be actually quite common. And we're going to discover that algae farming is actually something that human beings are increasingly doing. The next one is one of the major problems that attach to exploitation of the oceans. And that is that the ocean floor is extremely rich in minerals. And many of those minerals are lying on the surface or close to the surface of the ocean floor. And these are minerals with extremely high value, as we'll hear. And things like cobalt, copper, nickel, even precious metals like gold and silver, phosphates, all of these things are extremely valuable in commerce. And these resources currently are not heavily exploited, but with the development of technology, these are beginning to be exploited, and with some really drastic consequences for the oceans. But probably the most important thing of all that oceans do is they are culturally and aesthetically and spiritually important to human beings. More than 40% of the global population live within 20 miles of a coastline. And if you want an appreciation of the importance, just psychologically, of the ocean, what do we think of, when we think of a truly peaceful, stress-free, de-stressing environment? We immediately imagine things like going to the beach, swimming, diving, all of these things, just watching the ocean, watching the things that live in the ocean. These are not minor pursuits of human beings. They are major pursuits of human beings. And when the ocean is degraded, so that cultural experience is also degraded. Just think, for example, longing to go to a beach. You've been to a beach maybe in your childhood that you remember, or that you visited often, and you're dying to go to the beach again, and you go down there and it is littered from one end of to the other with plastics, piled up on the flood line. How do you feel when you see that? That is how your experience can be degraded as the ocean is degraded. So let's talk first about this, about our use of the oceans as a source of food, because it's tremendously important. So I'm going to show you here the exploitation of oceans from 1950 up till 2021. And I just want you to observe a couple of things. First of all, keep your eye on this here, on this scale up here, because it's going to change. When we start in 1950, it goes up to about 3 million tons there. So that spelling of ton, that means it's metric tons. So that's 2 million metric tons of fish that are being extracted from the ocean. And in this case, in 1950, the most important nation was Japan. The names of the nations are listed here if you don't recognize their flags. But what I want you to particularly notice is this one here. This is China. And keep an eye also on, where am I? Oh, sorry, there we are. The United States here. So in 1950, United States and Japan were the top fishing nations. And we're going to watch now what happens. Remember, keep your eye on China in particular and on the United States. And we're going to see if it works. Yes, here we go. Look here. Watch that. Okay, now watch China. Watch China as it comes up. There goes Japan. Japan's maintaining its fisheries, but it's not gaining. Peru was a major fishing nation. It reduced its impact. Here is China. Now watch this. Watch this. 10 million tons. By 1990, China takes over, undergoes some political difficulties, but recovers. 10 million, 15 million tons. And it's going to stabilize at about 15 million. So this is the nation. China is the major oceanic fishery. China has a huge fishing fleet, and its fishing fleet ranges all over the world. And they operate on a system where there are ships which actively fish in a fishing area, and there is a mothership, huge ship, container ship, which is completely refrigerated, which receives all the fish from, and then sails off, delivers its cargo of fish, and then returns to the fishing area. They use industrial style nets in various high-tech things to do their fishing, so they are able to reap a huge crop from the areas that they fish. United States is still a major contender, but not only about a third of the amount that China uses. And that, of course, is due to two things. First of all, China's population is very, very much bigger. But second of all, there is a cultural association, and fish is tremendously important in certain nations. And there is a demand for fish, which is so great that they are required to resort to these kind of industrial mechanisms to actually get enough out of the sea. But that, of course, has its consequences. And there are some nations here which used to be major fisheries, major fishers, let's put it that way, which simply don't appear. One of them that you may have noticed dropping off this top 10 or whatever it is was Britain. Britain used to be one of the world's major not industrial, but major fishers, and depended very heavily on an Atlantic fishery. And that we'll see now, that became non-viable for them. And they're no longer, they mostly buy their fish from other fishing nations. So here we are, and here's the major problem with that. We have referred to this briefly in other classes, but the dependence on the ocean as a source of protein for populations has resulted in us over-exploiting the stocks. And those, when we talk about over-exploitation, what we mean is, as you'll discover when you watch some of the videos that I have put up for you, when we take out product faster than it can be replaced by the standing stock of the resource. So we've got let's say we have a population of fish, of adult fish, which are reproducing, and we take out the progeny continuously. That is fine. That means that the population stays relatively stable. But when we start taking out the progeny plus the adult parents of it, the population begins to decrease. It is then non-sustainable. This happens no matter what you're talking about. It's not only fish, it's anything. If you start to do that, effectively what you are doing is, instead of using your interest, just think of it like a bank balance. Instead of using your interest, you're using your interest and you're drawing from your capital. And what is going to happen? Your bank balance is going to start decreasing. It's exactly the same thing. We have a classic example in exploitation of marine mammals, and these, particularly the whales. And here is a tragic story, but also with a little bit of a triumph at the end. And this is the blue whale, the largest mammal, in fact, the largest animal ever to have lived. Much bigger than any of the dinosaurs or anything like that is the blue whale. And they're huge, magnificent things. But being huge like that, they are also a very valuable resource. And it needs to be explained that in Europe, in particular, or worldwide, I suppose, but there was a demand for whale because for two reasons. First of all, the meat could be used. That was one thing. And that is often the source of the reason that indigenous populations go whaling is to eat meat. But of course, if you're going to eat whale meat, you have to get it back to shore before it rots. So whale meat was not a major source of protein for general population, although it could become available. No, what was important about whales was their fat, was their oil, the oil container, because in the 18th, 19th century, before fossil fuels began to be exploited as a source of both of heating energy, whatever, but also lighting, they used whale oil in lamps, for example, but they also used it in cooking and in various industrial processes. And you'll remember this is the period when the Industrial Revolution is starting. They need sources of oil, and they in general used whale oil. And so here, have a look here, and you'll see in the 1800s, here's the population of blue whales. It's between 350,000 and about 250,000 worldwide. The population stays relatively stable. And the reason for that is that they were using primitive whaling methods. And these were the days when guys went out and they went in small boats from a larger vessel. They speared, harpooned a whale by hand, killed it, hauled it back to the mothership, and processed all the blubber. They rendered the blubber. They just heated it until all the fat melted into oil, gathered that oil, and transported that back to shore. It was a very primitive operation, very inefficient. So they were here, what they were doing was they were just taking part of the population. They were not affecting the general stability of the population. But look around here. This is when industrial whaling started. This is when they started using harpoons that could be fired from the mothership, for example, because they were explosive. Effectively, the harpoons were turned into rockets, which they fired into the whale, and they carried with them an explosive charge. They killed the whales with high efficiency, close to the ships, hauled them in, processed them very rapidly, and while they were processing, they could carry on hunting for more whales. They started to haul out whales much, much faster than the whale population could reproduce to replace itself. And within a period only of about 25 years, they brought the blue whale population down to around about 10,000 globally, as opposed to its high up here. They brought it down, right down into the thousands. They didn't stop whaling. There was a time when they began to move to other whale species and gave the blue whales a bit of a break, but then recommenced the blue whale fishery and brought it almost to extinction. And at the very last minute, when blue whales were literally in the hundreds, that was all that they were globally, they were down to the hundreds, they introduced a whaling ban on blue whales, not on everything, but on blue whales. And the last intentional kill of a blue whale was by Japan. Japan is a major whaling nation and still is. The last intentional kill was in 1978, something like that. Then a total ban was placed on a globally enforced ban, and you cannot sell blue whale meat, you cannot sell any product from blue whale. And the population has begun to recover now in the thousands of blue whales. So this is a typical story. A high population, a useful population gets overexploited, and it's overexploited profitably for a while, and then it crashes, and then we run in and we try to repair the situation by putting a ban on, but we've got a very long way to go from our current populations back to the original population. Now, this has a huge effect on entire ecosystem functioning, because you're taking out the largest animal that has ever lived from these ecosystems. That has got to have effects downstream. It's a similar story right here. This is the cod fishery, and this is one of the reasons why Britain is no longer a major, Britain no longer has a major fishery, because this fish, the Atlantic cod fishery, was one which was heavily exploited, primarily by Britain, but then also by the United States and some other European countries as well. So here we go, similar story. We have primitive fishing methods right up until here. There were not primitive nets, but old style nets. They were not high-tech nets. They didn't have high-tech spotting devices to find shoals of the fish, etc. So they were able to, the population was able to be maintained. Now, this is fish landing, and this is in tons, but this is a good measure of the size of the native population of fish. Come 1950, industrial fishing begins, high-tech nets. Nothing gets away from these high-tech nets. They are easily found because they've got sonar and all sorts of things operating to find the shoals. The fish landings increase and increase and increase. Everybody's happy. People who like fish, they're getting lots of fish, they're getting cheap fish, and the fishery is making a fortune. And then what happens? We overexploit. Here we are taking out all of the parentage along with the progeny, and the bank balance crashes, and it ultimately goes bankrupt. And when it goes bankrupt, then all the fishery dies. The fishery dies because it's expensive. It's expensive to do all those things. But when you're pulling out masses and masses of making a huge profit, then you can afford to do it. But as it gets more and more difficult to do it, so eventually the fishery dies. And it either dies completely or people move on to another species to operate. But the Atlantic cod fishery is still in a state of recovery. It is still not being exploited as it could have been if they had tried to maintain the stocks. So this is a huge problem. And it's a very human problem, of course, that we just want to make use of. Hello? For some reason. I do not know. Wait, sorry. There we go. Okay. Here's our second, so with overexploitation, we have to keep that, think about that. Here's our second problem. And this relates, of course, we've talked about this briefly before, and this is the problem of ocean warming. And ocean warming is due to climate change. And as you remember, we talked extensively about climate change, about the increase in temperature, surface temperatures, due to increase in carbon dioxide and other greenhouse gases in the atmosphere. And this is resulting in warming of ocean waters as well. So here, for example, we see it particularly, again, it's 1950s. It seems to be the time when we begin to measure all of these things, the great acceleration. We begin to see increases in global ocean temperatures. And we now have a global temperature increase of about 0.8, between 0.8 and 0.85. This is 0.76 in 2020. Now, this global increase in temperature of less than 1 degree centigrade doesn't sound like a huge amount, but it is a huge amount. It's a huge amount to organisms that live in the ocean because they are adapted to the very constant temperatures, and they have a very narrow temperature range in which they will their cells can operate efficiently. And either too high or too low, the efficiency of metabolism falls. And if you raise it too high, they will begin to die. And there's a grave concern about this increase. This increase in ocean temperatures may be one of the most profound changes which global climate change is producing. So the classic impact of this the global temperature, the ocean temperature rise has massive effects on almost all ocean systems. But we'll take this one just as an example because it is such a clear and catastrophic effect that we can observe now virtually every year. And I'll just explain. Corals are an organism, they're a colonial organism. They have a skeleton of calcium carbonate, and around that calcium carbonate skeleton, there's a very thin layer of animal tissue. And embedded in their cells, there are organisms called zooxanthellae. And the zooxanthellae are you can think of them as being algal cells. They're not really algae, but they are photosynthetic. And they live in symbiosis with the animal which is the coral. So you've got actually two very different organisms living together, and they're mutually beneficial to one another. The zooxanthellae are provided with lots of carbon dioxide, which they need for photosynthesis. They are sheltered and protected, and they are kept in a relatively constant metabolic environment. So they function very, very well. And in return, what they do is they provide, during the daytime, they provide oxygen to the corals, but they provide lots of sugars and things like that from the process of photosynthesis. So the presence of these zooxanthellae are what give corals their color. Usually corals are brown. There may be different colors, but usually the zooxanthellae contribute a fundamental golden, brown, green kind of color to them. There's an unfortunate impact of warming temperatures, and that is that the zooxanthellae do not work well. They do not metabolize or photosynthesize well if the temperature rises. And if the temperature rises too high, they will actually leave the coral. They will escape from the coral and go into the ocean water itself. And the zooxanthellae don't die. They just become part of the planktonic community. When this happens, the corals turn a ghostly white color. They lose all their color. If you then lift the temperature, if you lower the temperature, if you lift that temperature stress soon enough, the zooxanthellae may return to the coral. The coral may take in zooxanthellae again. But if the temperature rises too high, that will not happen. And if that continues, the corals die. And unfortunately, this is something which is now happening. It used to be a very, very rare occurrence. It is now happening virtually every year, especially on the greatest coral reef of all, which is the Great Barrier Reef in Australia. Here's the typical situation. Here's a coral, a normal coral. Here's a bleached coral. And you can see whole huge, huge areas of reef in a prolonged heating event. You'll see huge areas of the reef that are completely ghostly white. And this is leading to the loss of corals from the reefs. The reefs also become weakened. The coral becomes weakened, cannot lay down a proper skeleton, and they are very easily damaged by way of action. Normally, they are very strong and they survive even hurricanes and things like that. But weaken, they start to crack, break off, die, and they are not replaced. So this can be absolutely catastrophic. So this here is the east coast of Australia, and this is the Great Barrier Reef, stretching thousands of miles all the way down the coast here. And this was a bleaching event which took place, I believe, in 2017. And the red here is catastrophic bleaching. That is 60% or more of the corals are bleached, which is just a huge amount. And then there is a loss of about 40% or so of those, complete loss of about 40%, around about there. Yellow and orange, not so bad, but still it's 10 to 60%. Here in the south, the corals were normal in this event. But unfortunately, in the years following this, the bleaching events have extended further and further, and this year's bleaching event was the most catastrophic of all, and it extended all the way through the entire Great Barrier Reef. This is purely an effect of global climate change. Okay. Problem number, I'm sorry to hit you with all of these problems, but I would love to be telling you about all the wonderful things that happen in the oceans, but this is our task, is to find out how our impact on ecology and the environment. So this is now, I'm going to talk about something which is a nascent problem. That is, it's not in its full-blown form yet, but the warning signs are all out there. And that is that the ocean floor, as I told you at the beginning of the class, the ocean floor is a source of minerals which are extremely, extremely valuable. And they're extremely valuable in not only as precious metals and things like that, they are extremely valuable industrially and are heavily used now in technological advances in computers, electronics, all of those sorts of things. So there are various kinds of minerals on the ocean floor. And the first that I'll tell you about, they're called polymetallic sulfides. And these often are rare and very valuable precious metals. So, for example, silver, gold, those platinum, those kinds of things. And these occur very specifically at hydrothermal vents. Now, a hydrothermal vent is a volcanic vent. It's an area of the ocean floor where seawater seeping into the sediments is heated very deep below the surface and then rises up to the surface and belches out of fissures in the crust, in the oceanic crust. And here is one here. This one is called a black smoker because it belches this black color. Now that black is in fact metallic. These are metallic salts, and they are sulfides. They are full of sulfur, and they begin to accumulate, and they actually will form chimneys that this water belches out of. And these chimneys are extremely valuable because they consist of these metallic salts. And what people would like to do is go and farm these, go and mine these chimneys. And unfortunately, these chimneys also have very, very unique ecosystems associated with them. I'm not going to go into it, but I'll simply tell you that there is a high biodiversity associated with these chimneys. of all sorts of different things occur there. And so exploiting these, how are you going to exploit them? You're going to carve them up and bring them to the surface. You're going to dredge them, blast them, whatever, but you're going to destroy these chimneys and then haul them to the surface to process all the minerals. That's the first thing. The second type of mineral are called polymetallic nodules. And these are literally nodules. You'll see in the videos that I've given you. They are literally lumps of rock. The rock is composed of, again, of metallic ores, in particular manganese, but including various other things as well, cobalt, iron, all sorts of things in these nodules. The nodules usually form around a little piece of shell, a fossil. Also, they are very, very old. They only accumulate, they only grow extremely slowly, but they litter the ocean floor. But associated with them is a whole community, a whole benthic community. So that is the next polymetallic nodules. The next kind, I told you to keep an eye on seamounts. The seamounts are old volcanoes, and because they are volcanic, they have accumulated lava layers, basalt layers rather, which are very, very rich in iron and manganese. There are also other heavy metals associated with them. And these seamounts are beginning to be exploited as well for their minerals. So there's a lot of interest, of course, in getting down there and using new technologies like robot-propelled scrapers and dredgers, etc., and then bringing the stuff to the surface and processing. But there are major problems associated with this. And the first is, as soon as you start scraping up stuff from the ocean floor, you raise sediments, which never, ever in all of the history of the ocean floor have those sediments been stirred up. They may be transported for a very, very long way, and they may actually smother, as they settle, may smother other communities that they impact on. The second thing, of course, is this is scraping up these minerals from the ocean floor or destroying hydrothermal vents. Whatever you do, you are destroying that community. You're destroying the benthic community, and that is going to result in a massive biodiversity loss. And I return to something I said at the very beginning. We do not understand. We do not know. We know hardly anything about the deep ocean floor. Thirdly, the activity of these machines on the ocean floor is going to create something which the organisms seldom are exposed to, and that is a lot of noise and probably a lot of light as well. And in addition, they are going to be subjected to vibration through the ocean floor, all sorts of things that these organisms have never been exposed to before. We do not fully understand the functioning of the ocean. We do not fully understand how the ocean floor interacts with the rest of the ocean and even with the surface ocean. And there are interactions amongst them. We know that the ocean floor is a source of carbon sequestration, that carbon is actually being taken out of the water, dissolving into the water from the atmosphere, being taken out of the water and being built into structures on the ocean floor. For example, calcium carbonate, limestone, which is continuously made here in hydrothermal vents, on the ocean floor, in animals, in organisms. We don't know what impact this is going to have on them. And if the first thing that these mining companies will tell you is that whatever they are doing, they're only doing it over a very small area of the ocean floor. And I just want to show you this. Now, here are the continents. Here's the ocean floor. And all of these areas, shaded areas, the gray, this gray shaded area, those are areas where there are nodules, polymetallic nodules, and those are all open for exploitation. Now, there is a system of governance, and this is the United Nations Seabed Authority. And they are engaged in mapping all of these areas, deciding which can be exploited, which are to be left unexploited, and those to be exploited, who gets to actually do it. So countries get assigned a certain area. The one at the moment, which is of particular interest, is this Clarion-Clipperton zone in the Pacific. And here you can see all of the countries which applied for licenses and were granted them to exploit this. And these are nodules which are being, which are going to be grabbed and used. But have a look here. These areas here are ocean crust and seamounts, which are going to be used. And all along here, you see these blue dots here. These are all hydrothermal vents, which are going to be exploited for polymetallic sulfides. So there is potential for exploitation of much of the ocean floor. And the UN Seabed Authority is attempting to set rules, but we need to understand that if these seabeds are disturbed by this, it will take an enormously long time for them to recover. So this is, I say it's a nascent problem because these are not being fully exploited yet, but you can expect that as time passes, they certainly will be. Okay, sorry to give you this whole long list of problems, but our fourth problem that we need to talk about is the problem of increased dissolved carbon dioxide. Now, we've already talked about this briefly in our discussion about global climate change, but I just remind you that when we dissolve carbon dioxide in seawater, we actually cause the pH of the ocean water to fall. That means it becomes more acid. Many organisms, microscopic organisms, these are little amoeba kind of things which build a shell called foraminifers, mollusks, echinoderms like sea urchin, that sort of thing, and of course the corals. These all depend on a calcium carbonate skeleton or shell. And when the ocean pH falls, again, it doesn't look like it's much to fall from 8.15, which is down to 8.05. That doesn't look to our eye like much, but when you're an organism which is adapted to a very, very constant pH, which is normally the case in ocean water, when you're suddenly subjected to this sort of change, building calcium carbonate shells becomes extremely difficult. And maintaining, for example, corals begin to struggle to maintain their size. They cannot build a skeleton faster than it gets eroded by a wave action, that sort of thing, and they begin to decrease in size. They also weaken, so that if they're hit by a hurricane or something like that, they shatter and break. So this is having a tremendous effect on many organisms in the ocean. Okay, problem number 5 is something that I'm sure you are all aware of, and this is marine pollution. Marine pollution takes the form of many different things, but we'll just talk about the most important. First of all, oil. Oil, the reason that oil is so important as a pollutant is that oil is transported by ship, and ships are subject to accident. Either the ship can actually founder, break, and release oil, or else there can be accidental oil leaks from the vessel transporting the oil, and sometimes it is deliberate. In particular, the way ships work, the way any transport ship works, is they will transport a product, right? And they'll fill their holds with oil, transport it somewhere, and then discharge it. Now, the ship can't go off with empty holds because the weight of the ship is disturbed. So what they do is they fill the holds with water. And then they are, as they approach the place, they go back and they approach the place where they're going to load the product again, they begin to discharge that bilge water. And if they have used those tanks for oil, oil gets thrown out together with the bilge water. And this is a major source of oil pollution all around the world. Bilge water discharge is supposed to be very carefully regulated, but many ships are very negligent about that and simply discharge their bilge water at sea before they arrive in port where they're going to where they are going to load. Now, oil is very, very toxic. It's when it's first released, it contains compounds which actually dissolve in seawater, and those are particularly toxic. As the oil ages, it maintains its nuisance value, especially for marine organisms such as birds. Here's a poor pelican covered with crude oil. And so oil carries with it an enormous range of problems, especially when it impacts onto a coast. Our second major source of pollution in marine systems are plastics. And plastics, again, they can enter through deliberate dumping of plastics, which frequently happens either into oceans or into rivers. But plastics are also originate from landfills, for example. They even originate from littering in streets, in cities, because what happens, the plastics littered on the street, they go into the gutter, and the gutters flow down to the sea, and the plastics end up in the oceans. And not only is it extremely unsightly and completely ruinous, for example, to a tourist industry which depends on its beaches, but also the impact on marine organisms. And we've discussed that before. We saw that the great oceanic gyres, which accumulate huge areas of plastic trash, which has ended up in the oceans. In fact, about 1 million seabirds, it's estimated, it's probably an underestimate, 1 million seabirds a year are killed by plastics in one way or another. Just an example to show you how serious it is. This is a picture taken on the ocean floor of the Mariana Trench, 3.8 miles down, 3.8 miles deep, and look what they find. They find plastic bags bouncing around on the ocean floor. I'm surprised that they didn't find balloons, because balloons are also a major problem in oceanic systems. Okay, the next kind of pollution, we've done oil, plastics. The next one is fertilizer and organic waste pollution. As soon as you begin to put lots of nutrients into ocean water, nitrogen and phosphorus in particular, it funds the growth of algae. And those algae then overgrow. The ones which are shaded out by the surface algae die. Bacteria consume them, and all of the oxygen in the water is removed. And what we end up producing are areas of the ocean where the oxygen levels are too low. They are hypoxic. That means the oxygen is low. The oxygen gets so low that all organisms there either have to move or they die. And this creates what is known as a dead zone. And in the United States, one of the most persistent and regularly occurring dead zone is in the Gulf of Mexico. And you can see it here. This is a graphic of it plotted out according to the amount of oxygen. And this is actually a satellite photograph looking at particular kinds of algae which are indicators of eutrophication. And eutrophication is this process of overgrowth of algae, which ultimately leads to hypoxia in the water. There's an unfortunate aspect to this, and that is warm water can contain less oxygen than cold water. And as a result, as ocean temperatures rise, so the likelihood of these hypoxic events begins to increase. Okay, so now let's talk about something which is something of a solution, but which has its own problems. And this is the question of aquaculture, of actually farming organisms in order to use them. And aquaculture is, for example, aquaculture of fish. Surely if we grow fish by aquaculture, we will relieve the pressure on natural stocks. Now, in some ways, this is true, and human beings have actually done this for millennia. Here, for example, is a Hawaiian fish pond. So this is a very, very cunning system. It's built into the sea. So the sea, they allow flow of water from sea into the pond, back and forth, bringing in nutrients, bringing in food, all sorts of things. But there is a gate. There's a weir system. And the weir allows larval fish to come in. And then when they get too large, they can't leave. And they just stay in the pond growing and growing and growing until they can be harvested. It's a very, very cunning system, a very ancient system. And it was a very highly regulated system. They didn't occupy too much of the coastline. It was a completely sustainable system. And it worked really well. Now, in modern times, aquaculture is used for a huge variety of organisms, as I'll show you in a minute. And it has begun to occupy more and more and more of technological attention. So, well, again, we're going to go from 1950. And I want you just, I'm just going to flick back, okay? I want us to have a look. Here, we ended up with China, if you remember, stabilizing its catch rate at between 15 and 20 tons per year, right, of wild caught fish. So now let's have a look at how successful aquaculture is in providing equivalent amounts. So here we are. In fact, originally here in the 1950s, France was the most important aquaculture nation. But this is a mixture of two things. It's still accounted in here as frog culture. And also, but most of this is actually mussels. It's shellfish that they are cultivating. So now let's watch. We're going to start off low. Look at this, 0.1 million tons produced per year. Again, watch for let's watch China. Boom, there it goes. And it never loses pole position. But look at the amounts. Cultural Revolution, it falls. Now they're back on track. 0.6 million, 0.8 million. 1 million. India also an important producer. United States somewhat. Look at it, 4 million tons, 6 million tons, 8 million tons, 15 million tons, exceeding their wild catch, 20 million tons, 30 million tons by 2010, 40 million tons by 2015, and we're going to stabilize out at about 45 million tons by 2021, far exceeding their wild catch. Other nations, these are actually substantial amounts that are being cultured here, that are being farmed here, but they are far eclipsed by China's efforts in developing aquaculture. So, sorry. So there are various ways in which this is done. Here, this is in Peru, and these are salmon pens. These are net enclosures, which are entirely enclosed, and they bring in either larval, or they're either eggs or larval salmon. And they put them in here, and they feed them, and they grow them up, and then harvest them and sell them. So this is actually a highly profitable venture, although the food is extremely expensive. And in fact, the food is mostly composed of fish meal products, because salmon are actually carnivorous. They will eat the pellets, but they need animal protein in order to grow properly. So that's fine. The system looks like a pretty good, sustainable way of doing things. And this is used for many different fish, but salmon is probably one of the most commonly cultivated in these ocean pens. Now, these are, I told you, cultures many, many, many different organisms. Seaweed, oysters, clams, mussels, scallops, shrimp, all sorts of different organisms. And the number of different kinds of fish which are either currently being farmed or which have potential to be farmed is enormous. And there's vary from relatively small fish to extremely large fish like sturgeon. And these are all fish which have a very, very high value on the market. So the problem is that this is not a benign, entirely benign industry. There are a huge number of problems associated with aquaculture. And probably one of the most important is this issue of what they are fed. They are fed a very high diet, a diet that is very high in oils and in animal proteins. And they may also be plant proteins, but the point is that what we're doing when we dump the food into the water, we're actually enriching the water. They may be eating a lot of the pellets or whatever it is, but they also leave a lot, and a lot dissolves out or leaches out into the water column and is then dispersed away in one way or another. In ocean pens, it's very easily dispersed into the coastal environment. Inland ponds and things like this, they have to be continually turned over. The water has to be continually refreshed, and the wastewater goes out to sea. So that is problem number one. Problem number two, if you're feeding an enormous amount of fish a very rich diet, they're going to poop a lot. And they produce, they also produce urine, and all of these are very, very high in nitrogen, especially. And so you are actually polluting the environment. You're enriching the environment with nitrogen, and you run the risk of eutrophication. There are all sorts of other problems associated with this. And one of the things to think about is that what we're doing in these systems is we're actually setting up a monoculture. You'll remember all the problems we talked about with monocultures in plants farming before. The same kind of ideas apply here. If you've got one group of organisms which are all closely genetically related and you're growing them, they are ripe for disease. And a disease can spread inside that population and then spread out, because these essentially are open systems to the environment. We may keep the organisms we like inside, but they're open to the environment in that small things and dissolve things, etc., can leave to the general environment. And the first thing is that these systems have proved to be incubators of disease which can spread to wild populations. The other major problem with this is these pens and things and ponds and everything are imperfect, and things will escape from them. And this is particularly dangerous when we are either growing a population in the pens, wherever, which is non-native to the area it's been grown. For example, in the Pacific West coast of the United States, Atlantic salmon is farmed. And there have been several instances where that Atlantic salmon has escaped into the environment. And they have, in some places, have actually established themselves as a population, competing with native fish. The second problem is many of these cultivated organisms now are genetically modified, and they are modified, the salmon in particular is modified to grow extremely fast and to feed extremely efficiently. And if they escape, they outcompete the native fish completely. So these are really major things to think about in aquaculture. But if it reduces the pressure on native stocks, then if these problems can be managed, then it is advantageous. As you saw, China is now producing more from aquaculture than it is drawing from the environment. And the more aquaculture there is, the more successful it is, the more the pressure will be relieved on native fishing. Now, I do want to mention just one organism, a farmed organism, which is of particular importance. And these are shrimp. And shrimp and prawns are widely cultivated in many, many different areas of the world, especially in tropical areas. And what they do is they will go in, they will clear coastal areas and set up these fish ponds. You can see here they can be enormously extensive. And what they have cleared out, this is a form of deforestation, because what they're doing is they're clearing mangrove forest. Mangroves are extremely important coastal organisms. And they form huge forests which shelter the inland from storms and storm surge and all that sort of thing, but are also very, very high biodiversity areas. And they are being cleared out for shrimp farming, which is an extremely profitable system, a very profitable crop, and supplies markets all over the world. So because of the high profits, very often the environmental impacts are just simply overlooked. So this, not only do they clear the forest, but these are also the source of a tremendous amount of organic pollution, which then ends up going out to sea. Okay, so there are efforts being made to govern the oceans, but I'll mention a couple of problems associated with them. First of all, there is an international law of the sea convention, or the LOSC. The law of the sea convention sets up a really rigorous legal framework to govern how the seas are used. The first major thing about it is that the law of the sea sets up an economic exclusion zone, that is an area away from the coast where only the country adjacent can actually use that area. But then in areas which are open, it attempts to set rules and regulations for exploitation of all aspects of the ocean. There's also a sub-organization to this is the United Nations Seabed Authority, which I've already mentioned, which governs mining. And and that allocates the mining concessions, etc., and regulates how mining is done. There is a major problem with the LOAC, and that is that the United States refuses to join it because it sets rules outside of Congress, which the United States would have to adhere to. So they object to having external body set rules for how the United States should behave. There are also the Organization for Economic Cooperation and Development, the OECD, that the United States is a member of, and they have an initiative on ocean conservation and sustainable use. And you can go here to this link if you're interested to see. Then there are an enormous number of organizations, non-governmental organizations, looking at various aspects of ocean conservation. And there's a rather more loosely formed umbrella body called the Deep Sea Conservation Coalition. And that is just a rather loose alliance of international organizations cooperating with one another to promote conservation, especially of biodiversity. And they have a particular interest in mining, in seafloor mining. So what can actually be done to improve the situation at the moment? We have an almost adversarial relationship with the ocean. We treat the ocean almost as if we deserve to be able to just strip it of all of its resources, and it should recover. For centuries, we've used the oceans as a dumping ground for our trash, for our sewage. We've then gone out to sea, overexploited its resources, slaughtered its populations. And always we look at the ocean and we think it's so enormous that it must be able to cope with all of the things that we do. It's turning out that it can't, that we can actually have a tremendously deleterious impact on the functioning of the ocean. There are some things which all of the organizations I've mentioned before are trying to promote. The first is the establishment of marine preserves. Marine reserves are areas which they're not small, they are large areas encompassing coastline, estuarine, and then pelagic offshore areas, all contiguous with one another so that they can function as in an as natural a system as possible. And these are not just to provide protection for organisms which live in them. These areas where they have been established, it has been discovered that they act as nurseries for organisms which can then move out and repopulate overexploited areas. So they are tremendously useful, not only aesthetically and everything else, because you can go there, you can see naturally functioning systems, but they also act as a reserve for populations which have been decimated elsewhere. Something has to be done about preventing plastic pollution. Many nations now are recognizing that plastic pollution is not benign. In fact, that it has could possibly have some very, very serious biological effects as well. When it is large, like a bottle or something floating in the ocean, that is one thing. But many of these plastics have extremely long life, that we heard in another lecture, but they also break down into very, very small particles. And those particles end up inside organisms. And yes, they end up inside us as well. You eat fish, you are eating microplastics. If you eat oceanic fish, you are almost certainly eating microplastics. And the impact of those microscopic pieces of plastic in our tissues is not known, but it is surely not a good thing. Various places have put in river barriers to trap plastic floating down. And then there are also some deep ocean cleanup efforts. You may have heard of these ships with huge booms that are going out, for instance, to the Great Pacific garbage patch to try and clean it up. Chemical and organic pollution should be controlled by a mixture of law and of education. The first major source of organic pollution is poor sewage treatment, putting into rivers and directly into the sea poorly treated or untreated sewage, which is extremely rich in nitrogenous and phosphate products. The second thing is to limit the amount of farmland fertilization and to make farm fertilization more efficient, and also in many areas of the world to get gardeners to stop fertilizing, to stop growing lawns, for example, which require a very high fertilizer input, and much of which will end up in the adjacent coasts. The next thing is, of course, the strict regulation of the fisheries. We need fisheries to become dependent on science-based quota systems, on scientific-based systems which tell them how much they can actually catch sustainably, and then have very, very strict regulation to ensure that they are sticking to that. In addition, fisheries have to be regulated to limit the amount of bycatch that they take, organisms which they cannot use but which end up being damaged or killed when they are netted or however they are removed. And the last thing, the most important thing of all, and that is get global climate change under control, so that those things like global warming, global ocean warming are curtailed. And in addition, global acidification of ocean waters. Those two things would both be relieved by bringing global climate change under control. Okay, so that is it. And so I hope that illuminates, but please pay careful attention to the videos and readings which I've given you, which amplify much of what I've said. Okay.